All right, this is our ME106 project. This is going to be the smart greenhouse. Next slide. So the reason we decided to go with a greenhouse for today was because we felt that the use of mechanical and electronic systems together would allow the user to have a finer control over how the plant grows. Therefore, it would also be more efficient in terms of water use and energy use. And another pro that we were potentially considering was that the user could take care of most of the plant while they were away somewhere else. Next slide. So for our greenhouse, we're going to have two main controls and then subsystems from there. So the two main systems we have are an irrigation control and then a temperature control. The irrigation will be mostly handled by a pump and a moisture detector, and then the temperature will be controlled by a fan and a shade. Next slide. And here we have a view of all the electronics that we used. Next slide.
For my part, I'll be speaking about the irrigation aspect of our project. For the irrigation, we acquired a 5-volt centripetal water pump. The pump is activated by a 5-volt relay, which is in turn activated by the moisture probe, as seen here in the video. The 5-volt power was obtained from an external power supply. The relay also requires a 5-volt signal from the Pico. As the Pico output is only 3.3 volts, we utilized a logic level converter board, which bumps up the signal to the required voltage. Next slide.
For our shade servo motor mechanism, we used the servo motor, power supply, and a transistor. After doing some math and hooking all these components together, we went ahead and connected it to our Raspberry Pi Pico, and our code works as follows. So when shade is detected, our servo motor starts cranking and it starts to go ahead and open the shade. And then once light is detected, it begins to close the shade.
And this is also part of the temperature control system, and it's the fan. And so we pretty much connected the temperature sensor, which sends out analog signals, to the ADC pin, which is the analog to digital converter. That way, it can send out digital values since the microcontroller we use can't read analog signals. And so, like in this video, the fan pin in the code is configured as an output pin. That way, it can control the fan based on the temperature reading. So if the temperature is too high, it'll turn on the fan to regulate the temperature and cool it down. And then when it cools down past the threshold, it'll turn off the fan.
All right, here are the sources that we use for this slideshow, and this is everything we have for today.